Okay, here we go. So I'm going to go pretty quick. I want you to tell me if you need me to go through something more slowly, or if you have questions, please ask them, because if you do, other people do.
When you say recorded, does like it like all the sounds?
All the sounds. Yeah, it can. You know where to find these, right? These go to my YouTube channel. There's a link to it, to the geometry YouTube playlist, and they just go in order. So that'd be a good thing if you're having some issues. There's some parts of the chapter that you're not sure about. That'd be a great place over break to kind of take a look. Okay, so first one here. First one. They're asking us to find a distance. This is not a big deal, and it's, oh, thanks. This is one that we just need to, you guys need to just get this. It's time now to just get this. It's not hard to do, and it might take a little practice, but that's that time. I mean, if you need to do that, then do it. I'm available to help you, but we got to get through this part. Distance formula. We're going to use it forever. You just need to know how to do it. So our distance formula, we know, is just what? Square root of, good, delta x squared plus delta y squared. And so really all we have to do here is just find out what delta x and delta y are, plug them in, and I would claim this is one that I think everybody should get 100% right on the test. If you haven't, and on your retake, if you've already taken it, on your first take, if you haven't taken it, because it's a calculator question. All you have to do is just find out what those numbers are and plug that square root into your calculator and get an answer. That's it. There's really nothing too horribly complicated about this. So delta x. Now we've talked about how to do this in the best possible way. So Alec, what are the two numbers? What are our two x values? Good, -4, -9. Now which one? You write there. You tell me what to write here. Delta x is blank minus blank. What do I put? Good, -4 minus -9. Exactly correct. Why did you choose to subtract -9 from -4? Because -4 is bigger. Good. So what is -4 minus -9? 5, right? Because I'm adding 9, so I get 5. What about delta y? What are we going to get for delta y? What do you think? 10 minus 2. Good. Bigger minus the smaller. So 10 minus 2 equals 8. And so then our distance formula just gives us the square root of 5 squared plus 8 squared, which is what? 25 plus 64. So the square root of 89. And then all I have to do, this is no big deal. All I have to do is just go on here and find out what that is, right? Square root of 89, if I plug that in my calculator, is that decimal. So rounded to the nearest tenth, how many decimal places is that? 1. So I look at the second decimal place, and if it's a 5 or bigger, I gotta round up. If it's not, I don't. If it's not, I round down. So what's the answer? 9.4. That's it. So that's what I would input. I'd get it exactly right. Okay. One more thing I'll say about this. There's another way you could approach this. The delta x and the delta y. I think it's better to just always subtract the smaller from the bigger, but what if you didn't? What if I got answers -5 and or -8? There's another strategy you can take when you square numbers, and I can't remember if I've mentioned this or not. This works in all situations. Whenever in life I am squaring a negative number, I know I'm supposed to get a positive answer, right? Because negative times negative is positive. As I've mentioned, it's easy on a calculator to make a mistake and accidentally get a negative answer when you square a negative number. So another way you can always deal with this is, in any situation when I'm squaring a negative number, instead, what do I put into my calculator maybe? The positive number, yeah. If I'm squaring -137 on my calculator, why not just put in positive 137 and square it? And then I know I didn't make a mistake, because I know the answers are going to be the same, right? So that's another way to approach it. Okay, questions? Okay, good. All right, this is one, I'd say this is another one that you just, if you need to stare at it a little bit, then spend that time. But I think we're getting better at this. This is kind of a three-dimensional thing, and this is where it just takes a little while to kind of wrap your brain around how to think about this three-dimensionally and what it means to be coplanar. Spent some time talking about that last week. Any 3 points defines a plane, and so if I'm given these 3 points, points R, P, and O, there is only one possible plane that's going to go through those 3 non-collinear points, right? That plane is going to contain an infinite number of points, but only one of them is going to be a vertex on this shape. Which one is it going to be? Q. Yeah, it's going to be Q, isn't it? It's going to be the plane that kind of cuts down diagonally from the front top to the bottom, to the back bottom, right? That's it. So the answer is Q. And I don't really know how to make that there's no trick to that. You just have to kind of get it. Just look at it and stare at it until you see the plane. Okay, this is distance formula again. This is one where, this is probably the harder kind of distance formula problem because this time I cut off the question, but what it was asking for is an exact distance instead of just a decimal distance. So same deal as before. What's delta x this time? What minus what? -6 minus -11, which is plus 11, which is what? 5. And then delta y is, okay, -8 minus -10, which is plus 10. So what's that going to give us? Christian, what's that going to give us? What's -8 minus -10? Yeah. Yeah. 2. Yep, you're right, 2. So then our distance is just the square root of 5 squared plus 2 squared, right? So that's what, 25 plus 4, so wouldn't that be the square root of 29? Okay, so then all we have to do is ask ourselves, okay, that's exact. That is the exact answer, but can it be simplified? Is there a perfect square from our list that's going to divide evenly into 29? No, there's not. 4 does not go into it evenly. 9 doesn't go into it evenly. 16 doesn't. Obviously 25 doesn't. The other ones are too big. So that's our answer, right? We can't do anything to this. That's just how we leave it. Okay? All right. This one. Okay, this is a really easy problem. I can tell you why I think most people missed it. There's 2 things, looking at all the responses that people gave. There were 2 things that happened that caused people to miss it. One of them was this. What if one of the possible answers was the ordered pair or the point with coordinates, how about 3, 3? Where does that go? Well, first of all, and I guess this actually involves the other mistake people made. Reading a graph is a part of this question. You got to be able to look at this and say, okay, well now, where is the point 3, 3? Do I just go over 3 and up 3 right there? Is that right? It's not, is it? Because on this graph, that's 0 and that's 2, right? And so that means that must be 1. And for every 2 increments, I'm traveling over 1 unit length, right? So I got to see that first of all. So 3 is going to put me over that far, over 3, and then up 3 is going to go to there. So that would be the point with coordinates 3, 3, wouldn't it? Okay, now here's the other question. So that was part of the reason people missed this, is because they didn't see that maybe they had to look at the scale of the axes and read the graph correctly. So they maybe don't go over just one box. They might have to go over multiple boxes to travel for each unit, right? The other one was this. If a point ends up being right there, is it in the interior?
No.
It's not. It's not. It's on the angle, and that's different. There were 3 possible places where a point could be. It could be on the exterior of the angle, in the interior of the angle or on the angle, which would be either side or the vertex. And so that one is not an example. That would be a wrong answer, right? We only want the ones that are on the interior, not on the angle. Okay, this is, I think, this one I just was wondering why this was such a bad problem, because this is actually a pretty easy one, but I think I know why. It's the word bisect that people weren't 100% familiar with, and that's an important, I think sometimes people think that bisect just means that it's going to cut the angle into two pieces. And that's partially correct, but there's more to it. Okay, yeah, the part is that the other important part of bisect is not only does it cut the angle into two pieces, but the two pieces have to be equal. Anytime you bisect something in geometry, that will always be the case. So what that tells us is that this little angle down there is congruent to that little angle right there, right? So if we were given, let's just say hypothetically, we were given expressions for angle UMH and HMA, then I would have just set those measures equal to each other, correct? And that would have been pretty easy, right? This one was a little different. This one told us something here. They gave us expressions for HMA, which is this guy right here, right? And that was, what was it, negative 5x plus 9. But then they also gave us an expression for angle UMA. But look at UMA. UMA is the whole thing, right? It's not just one or the other. So angle UMA was negative 6x plus 46. Right? So what's going to be the relationship between the big angle and this small angle?
5x plus 9 times 2 is that?
Okay, good. Right. So there's two ways to think about it, right? We could think about it as being this small angle plus that small angle equals the big angle. Or we could also think about it as being 2 times this small angle equals the big angle, right? Doesn't that make sense? That if these two have to be the same, what if this one had a measure of 35 degrees, for example? What would the big angle be?
70.
It'd be 70, wouldn't it? It'd have to be twice as big. And so we get the geometry relationship then. This one has to be 2 times as big as that one, right? So 2 times the measure of angle UM. Oh, sorry, I got it backwards, didn't I? The measure of angle UMA equals 2 times the measure of angle HMA, right? Okay, and then we just plug in expressions. So this was the big one, negative 6x plus 46. Hey, what's going on back there? Can we control our hilarity and, please? Can we manage that?
Yeah.
Okay, thank you. So 2 times the small one, negative 5x plus 9. Okay, so we just have to solve that equation. That's not a big deal, though. That's not hard algebra. You guys can do all that. I know you can because we've already gone through much harder algebra than that. What are the steps we go through to solve this? Yeah, good. We got to distribute the 2 first. Very good. So we got to distribute that 2, and that's going to give us negative 6x plus 46 equals what? Good. 2 times negative 5x is negative 10x, and 2 times 9 plus 18. Very good. And so now it's just a matter of solving for x. So Bailey, what are my steps going to be? Which side should I probably push the x's to here, do you think? Yeah, good. The left, because that's we want to get a positive number. Good. So we'll add 10x to both sides. And that leaves us with, what, 4x on this side? Now, what about the numbers? Our goal is to isolate x, right? So where should I push the numbers, right or left? To the right, good. And so what would I do to get the numbers on the right? subtract 46. So those go away. And then negative 46 plus 18 would be what, negative 28? Last step, divide by 4. Okay, and so then we get x equals, what's negative 28 divided by positive 4? Good, negative 7. They're not asking for x directly, but I need x to find the measures of these angles, right? Now, it would be easy for us to find, let's see, HMA, the measure of HMA is given to us by that expression, right? So all I do is plug in negative 7 and I get an answer. Well, let's get that answer. What is negative 5 times negative 7? 35 plus 9? 44? Okay, good. So we get 44 degrees for HMA. What should I probably get for UMA then? UMA is the big one. So what should it be? 88. We could check it. Negative 6 times negative 7 is 42. Positive 42 plus 46. Sure enough, I get 88. Okay, here's the part that I think when I look at the results, what people got. In some cases, they got both of those, but then they didn't get this one. They weren't sure how to get that one. But really, that's the easiest part of the whole problem. Shaw, what do we know that the measure of that angle has to be? Keeping in mind, if we look at the picture, that UMH is this small one down here. If we knew that this guy was 44, and the big angle was 88.
Isn't it the same as the...
Exactly, the same as that one, isn't it? Yeah, we don't even have to do anything, right? We just know right away from the picture that whatever we got there goes there. And we're done. That's it. Okay, so this one, we can skip this one. This guy. This is another one that's really a quick one. Now, if you look at these two angles, FLY is this big angle up here, so that's negative 10x plus 6 degrees, and then VLZ is this bottom one, right? And that's negative 8x plus 28. So what's the relationship, Brady, what's the relationship between those two angles? Yeah, their measures are equal, aren't they? They're congruent, so their measures are equal. What do we call those angles? Vertical angles, good. And so this is really a pretty easy one to solve, isn't it? We just are going to set up the equation where negative 10x plus 6 equals negative 8x plus 28. We'd push the x's to the right side, wouldn't we? So add 10x gives us 2x on this side, so we'll chase the numbers the other way. Subtract 28 and get what? Negative 28 plus 6, negative 22. Divide by 2 and get x equals negative 11. Okay? And so we got the first part, it's no big deal. Yeah, and then we just plug x in, don't we? So when we plug x in, but here's where you got to be a little bit careful. When we plug x into FLY, negative 10 times negative 11 is what? Positive 110. And you can use a calculator. So positive 110 plus 6 is positive 116. Now there's a tendency here to just plug 116 in here, right? And I get it, because these are the two angles for which we were given expressions, right? But you got to read this carefully. Is angle YLV actually this angle? No, it's not. YLV is this angle up here, right? And so they're asking about a different angle. That's okay though. If we know the measure of this one, if this one has a measure of 116 degrees, how could we find the measure of this angle without even having to do any algebra? Exactly. We know that these are a linear pair, and so their measures add to 180, don't they? So 180 minus 116 would just be, what, 64? Or, is that right, 64?
Yep.
So we get 64 degrees, and we're done. That's it. Very good. Okay, this one, Okay, same kind of problem. Very same kind of problem here. The only thing I'll maybe mention about this, I'm gonna go through this one pretty quickly. If we put in these expressions, ZDM, the measure of that angle is given by 10x minus 16. The measure of angle MDX, so that's this angle up here, is given by negative 4y plus 20. And then the measure of angle XDG, so down here, is given by 6x plus 40. And we're supposed to find x, we're supposed to find that angle, and we're supposed to find that angle. Okay. Really, this is almost the same exact problem, isn't it? We've got, now the reason I made these red and blue is because the blue ones have x's and the red one has y. When we're setting up an equation, don't we want to set up an equation that has only x's or only y's? That's definitely easier, right? So we'd use the same relationship we had in the last problem. These are vertical angles, so I could set those measures equal to each other, right? Just like before, solve for x, and then I could, so I'm going to get an answer there, and then I could plug that answer back in there to find the measure of that angle. And we get two of our answers done. Now the third one is asking for that angle. Same as before though, I don't need to solve for y, right? All I need to do is just find out what I get when I subtract that number from 180. And I got it, right? So we can take kind of a tricky little shortcut there. All right. This is an easy one, but people missed. I want to show you a way that I think you can think about this. I know the book talks about using the midpoint formula. You can, if you're comfortable with that, but I think there's an easier way. First of all, read the question carefully. And a lot of times what people do is they read this and they think, oh, I'm just finding the midpoint of those 2 points. And that's not what it's asking. It's telling us that A is an endpoint, and it has coordinates 2, negative 2. B is a midpoint, and it has coordinates 6, 5. And the question is asking for the coordinates of the other endpoint, C. How do we think about this though? Think what the midpoint really is. The midpoint is the middle x value and the middle y value, right? And so when we're moving from this endpoint x value of 2 to the middle x value of 6, just ask yourself, how much did x change to go from 2 to 6? Did it increase or decrease? It increased by 4. So I added 4, didn't I? Okay, here's your thinking. If I had to add 4 to get from the extreme endpoint to the middle value, that's only half the trip. I've got to do that again, right? I've got to repeat that same process to get to the other endpoint because this has to be the middle value, right? So if I add 4 to my middle value, what am I going to get? Yeah, got to add 4 again to the middle value and I get 10. What about the y value? Same thing. To get from negative 2 to positive 5, I add 7, right? So then I've got to turn around and add 7 more to that middle value to get to the other endpoint. So I get 12. How could I check it? Easily. I just want to see, is 6 the middle value of 2 and 10? Yeah, it is, right? It's 4 away from both. Is 5 the middle value of negative 2 and 12? Yes, it is. It's 7 away from both of those. So we got it. Okay, so here are the 2 harder ones. Now, you can't just throw up your hands and surrender on these because, how much time do we have?
4 minutes.
Oh, how much?
4.
4? Okay, we can maybe get this one. But you can't just not do this because you're going to see these all year long, and I made them worth a small number of points on this test, but in the future I will not do that. I'm going to have the expectation that you can do this on a test correctly. Next time we take a test on this stuff. So you've got to know how to do this. It's not that hard though. Let's just see if we may not get through the whole problem, but let's try. So this is the same kind of problem we were doing before. Only difference is we've got x squareds in it, which makes it look scary, but it's not that big a deal. So the picture, people are getting good at understanding the relationship. If we know that S is between R and T, then we can set up an equation. We know that the length of the short segment plus the length of the short segment equals the length of the long segment. People are good at that. That's not a problem. So RT, the whole length, must equal RS plus ST. Okay, so we've got expressions for that. We can set that up as an equation then. So we get 4x squared plus 4x, minus 423, equals RS is just 2x squared minus 232 plus ST is x squared minus x minus 125. Now that looks, I agree, that looks kind of scary. There's lots of x squareds in there, but all I have to do is collect like terms, right? Not a big deal. This side, we'll just keep everything over here for now. But on this side, if I collect like terms, how many x squareds are there? Well, there's 2x squared plus x squared. So those combine to give me a total of 3x squareds, right? How many x terms are there? Just one. So I've got a minus x, and then how many numbers? Well, I've got a negative 232 and a negative 125, and that adds up to what, 357? So minus 357. Okay, so where to go from here? These are a little different, right? On these, we can't isolate x when we've got x squareds in there. If it's a quadratic function or quadratic equation, I have to get everything on one side set equal to 0. I want to put them on the side where I'm going to get a positive number of x squared, so that's the left side, right? So I'm going to subtract 3x squared from both sides. I'm going to add x, and I'm going to add 357. So everything cancels from one side, and I just get a 0, right? On the other side, what am I left with? What's 4x squared minus 3x squared? X squared. 4x plus x? 5x. Negative 423 plus 357 is, what is that, negative 66. So that's my equation, right? X squared plus 5x minus 66 equals 0. I will give you some other methods of solving these in the future that might make this even a little simpler. But for now, what's that? Okay, good, our 6 and 11. Okay, we'll finish this last one up when we get back, and then you can retest. Have a great Thanksgiving. Eat lots of turkey.